Hello everyone. So in previous lecture we have discussed up to dimension. So welcome to lecture number 4, and in this lecture we will discuss different types of variables and constants and applications of dimensional analysis. So let's start the topic. So first topic is different types of variables and constants. Okay, so first we will discuss our dimensional variables. That means quantity which possess dimensions and have variable values. These are called dimensional variables. So for example, you may consider area. Area is having dimension, that is m0, L2, T0, and variable values. It may be 2 meter square, 2.5 meter square, 20 meter square, etc. So area, volume, like this we can write so many quantities. Velocity, force, these are some examples. Next, dimensionless variable. Next one is dimensionless variable. That means quantity which possess variable values but having no dimension. So we can write quantity which has no dimensions but variable values. For example, you may consider dimensionless variable. That means we can take the example of angle. Yes, angle is dimensionless but variable values. Yes, 30 degree, 40 degree, 55 degree, etc. Like this, we can say specific gravity. Yes, sin theta, cos theta, all trigonometry functions are dimensionless but having variable values. So like this we can write so many examples. Next is our dimensional constant. Next one is dimensional constant. Here what we have to write? Quantity. So you may write quantities which possesses dimensions and have constant values. For example, Planck's constant. It is having dimension but constant value. Or you may think gravitational constant, capital G. Gravitational constant. It is having dimension but variable values. Sorry, it is having dimensions but constant value. That value is 6.67 into 10 to the minus 11. Okay, its value. And Newton meter square per kg square is its unit. Yes, it is having dimension means we can predict the unit from the dimension. And for example, you may consider speed of light. That is denoted by capital C, whose value is equals to 3 into 10 to the power 8 meter per second. So dimension is L1 T minus 1 and having constant value. This is the constant value. Yes, so speed of light in vacuum. You may consider this example. I hope it is clear. And last one is dimensionless constant. Yes, another one is dimensionless. It is a constant quantity but having no dimension. So we can write quantities which do not have dimensions but have constant values. For example, you may consider pi, Euler constant. Yes, dimensionless constant. Pi value is 3.14. Euler constant, that is nearly equal to 2.71. Yes, having constant value and dimensionless. Any pure number you may consider, any pure number 1, 2, 3, etc. Any pure number having no dimensions, and they are constant quantity. So these are the different types of variables and constants. I hope these 4 types is clear to all of you. This is your first type, this one is second, this one is third, and this is your fourth variety. Yes. So next come to uses of dimensional analysis. So next come to our uses of dimensional analysis. So what are the different types of uses? Now see. So by the help of dimensional analysis, we can convert one system of unit to other system of unit. So first point we can write conversion of unit from one system to another. Yes. And second one is checking the correctness of the given physical relation or physical equation. Checking the correctness of given equation. Yes. And third one is to derive relation between various physical quantities. Yes. And fourth one is to find the dimension of unknown physical quantity. Unknown physical quantity. P dot Q means physical quantity. Yes. So one by one we will complete all these uses. Next, give heading principle of homogeneity. Next concept is principle of homogeneity. Yes. So what is this? Now see, as per principle of homogeneity, there are two principles. Yes. So first one is two physical quantities can be added or subtracted if they have same dimension. Yes. Second one is the dimension of both sides of a equation must be same. The dimension of both sides of a equation must be same. Yes. So let's understand these two principles in detail. Yes. So let us think as per this principle, what the principle is saying. Now see. The principle refers that if a plus b and a minus b, a plus b बोलो नहीं तो a minus b, जो भी, if a plus b or a minus b is meaningful, then remember, then dimension of a is equals to dimension of b. For example, 5 kg plus 2 kg, that is equals to 7 kg. So 5 kg plus 2 kg, that is meaningful. So 5 kg dimension is equals to 2 kg dimension equals to m1. But 5 kg plus 2 seconds, this is not meaningful. Yes, because both are having different dimensions. I hope it is clear. Yes. Another thing, so here first principle is clear. Two quantities can be added or subtracted if they have same dimension. The second one is telling, in any equation, dimension of LHS equal to dimension of RHS. That means if Z is equal to A plus B, a plus B is meaningful, means dimension of A is equals to dimension of B. And Z equal to A plus B, this is the equation. That means dimension of LHS must be equal to dimension of RHS. So moreover, we can say dimension of Z is equals to dimension of A equal to dimension of B. Similarly, if Z is equals to A minus B, that means dimension of Z is equals to dimension of A is equals to dimension of B. Yes, I hope this is clear to all of you. So let's start the applications. Okay, first application is conversion of unit from one system to another system. Yes, so let's discuss in detail with some numericals. Okay. First application is conversion of unit from one system to another. Yes. So let's think an example. Suppose length of a rod is equals to 5 meter. This 5 meter can be written as 500 centimeter. Yes. And if you write, this is your physical quantity Q is equals to 5 is N and meter is U unit. Exactly 500 centimeter. In 500 centimeter, 500 is numerical value and centimeter is unit. So in order to distinguish between these two systems of unit, let's write this is N1 U1, that means first system unit, and numerical value associated with first system unit, and this is N2 U2. Yes, so we can write it as N1 into meter, its dimension is L1, that means we can write M0 L1 T0. Yes, that is equals to N2 into, again U2 is centimeter, its dimension is M0 L1 T0. But in order to distinguish between first and second system, let's here write M1 power 0, L1 power 0, T1 power 0, M2 power 0, L2 power 1, T2 power 0. Yes, like this in general we can write, in general we can say N1 into M1 power A, L1 power B and T1 power C, that is equals to N2 into M2 power A, L2 power B, T2 power C. So from this we can say what is the value of N2? N1 into M1 power A, L1 power B, T1 power C dimension divided by M2 power A, L2 power B, T2 power C. So finally we can write the formula in this way. N2 is equals to N1 into M1 by M2 power A, then L1 by L2 power B, next T1 by T2, its power is C. So remember, this is your working formula. This one is your working formula. Okay. So let's solve one question by use of this working formula. So question is convert 5 joule into CGS system. Yes, this is our question. This is your question. So what you have to find? So you have to convert 5 joule into CGS system. First think, joule is the unit of which physical quantity? That is work or energy. Yes. So first you have to find which physical quantity is involved in this question. Yes. That means the quantity is work. So find the dimension. Work dimension is 1, 2, minus 2. M1 L2 T minus 2. So simply write A is equals to 1, then B is equals to 2, then C is equals to minus 2. Then here in left side you write first system, and in right side you simply write second system. Okay. So in given question, the first system is in SI and second system it is asking in CGS. Simply mention this one. Next, you write here N1 value is 5 and here N2 value is required. And your first system, as the first system is in SI unit, so M1 and L1, this is T1. So M1 value will be 1 meter, M1 value 1 kg, L1 value 1 meter, and this is 1 second. Similarly, M2, this second system is CGS system, M2 value is 1 gram, then L2 value is 1 centimeter, then T2 value is 1 second. Then simply you use the working formula. The working formula is N2 value is equals to N1 into M1 by M2 power A, then L1 by L2 power B, and T1 by T2 power C. Finally, you have to put the respective value. Put the respective values in its proper place. Okay. So N1 is our N1 is 5. Next, M1 by M2, that means 1 kg divided by 1 gram. Power A value is 1. Then 1 meter by 1 centimeter. Power B, that is 2. Then 1 second by 1 second, that is power C, that is minus 2. Then 1 kg means 10 to the power 3 gram divided by gram whole power 1. Next, 1 meter means 10 to the power 2 centimeter divided by 1 centimeter whole power 2. Then 1 second by 1 second is 1 power minus 2. Then gram gets cancelled out. 10 to the power 3 to the power 1, that is 5 into 10 to the power 3 into centimeter cancel हो गया. So 10 to the power 2 power 2 is 10 to the power 4 into 1 power minus 2 is 1. So final answer is 5 into 10 to the power 7. 5 into 10 to the power 7. So thus we can say 5 joule is equals to 5 into 10 to the power 7 org. In CGS, the unit will be org. So in this way, you have to convert the given system of unit to another system as per the requirement, okay, as required in the question. Yes. So I hope it is clear to all of you. Yes. So let's solve another question. Okay. Let's discuss another question. Our question is find out the value of gravitational constant. Find out the value of gravitational constant, that means universal gravitational constant. That is your capital G in CGS system. And it is mentioned capital G is equals to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Newton meter square per kg square. This is mentioned. Yes. So same thing. You have to convert this thing into CGS system. So simply write, in left hand side you may write first system, and in right hand side that is your second system. This is our second system. And in between these two, we have to write the dimension of capital G. We have already discussed capital G dimension is -1, 3, -2. So it will be -1, 3, -2. So to this, A is equals to -1, then B is equals to 3, C is equals to -2. First system is in SI unit. Okay, SI system. So here you can say first system is SI and second system is CGS. So in first system, and it is mentioned N1 value is 6.67 into 10 to the power -11, and N2 value is required for us. And first system is SI, so we can say M1 value is 1 kg, then L1 value is 1 meter, then T1 value is 1 second. Similarly, M2 value is CGS system, second system is CGS system. M2 value will be 1 gram, and L2 value is 1 centimeter, and T2 value, that is 1 second. Same thing, you have to put the use required working formula. So by the use of the formula, N2 is equals to N1 into M1 by M2 power A, then L1 by L2, then power B, next T1 by T2 power C. Yes, so we have to use, so 6.67 into 10 to the power -11, M1 value is 1 kg, divided by 1 gram, power A value is -1. Next, 1 meter by 1 centimeter, whole power, B value is 3. And third thing, 1 second by 1 second, 1 second by 1 second, power -2. I hope it is clear. Yes. So after solving, what you will get, this is equals to, here we can write N2 is equals to 6.67 into 10 to the power -11, yes, 1 kg, that is we can say 10 to the power 3 gram divided by 1 gram, whole power -1. Next, 1 meter is 10 to the power 2 centimeter divided by 1 centimeter, power is 3. Here power is 3. Next, 1 second by 1 second, that is 1. 1 second by 1 second is 1, and 1 power is -2. So this is equals to 6.67 into 10 to the power -11. After cancellation of gram, 10 to the power 3 to the power -1, that is 10 to the power -3. This is 10 to the power -3 into centimeter cancel होने के बाद 10 to the power 2 to the power 3, 10 to the power 6, and 1 power something, that is equal to 1. So final answer will be 6.67 into 10 to the power -11 -3, that is -14. -14 plus 6 is -8. Yes. So this is the value of N2. Yes. So we can say the answer is 6.67 into, we can say thus 6.67 into 10 to the power -11 Newton meter square per kg square is equals to 6.67 into 10 to the power -8 dyne centimeter square per gram square in CGS. The answer is in CGS because it is asking to convert this value of capital G from SI unit to CGS unit. I hope this one is clear to you. Yes. Okay. Let's discuss one more variety of this type of use. Yes, you may face the question like this. The third one is very important. This is the third numerical. So question is, in a given system of unit, in a given system of unit, one unit of mass is equals to 2 kg. Next, 1 unit of length that is equals to 5 meter, and 1 unit of time, it is given, that is equal to 5 seconds. Yes. So question is asking, then in this system 1 Newton represents 1 Newton represents. Options are 5/2 units of force, next 2 units of force, next 2/5 units of force, and next 1/2 units of force. 1/2 units of force. So how to solve this one? So our aim is to convert what? Here simply you have to write fast system, same as previous, try to maintain the decorum fast. So this one is second system. Yes, and this fast system is in SI because we have to convert 1 Newton into new system. So fast system is in SI and second system is new system, and the quantity is force, and force dimension is 1 1 minus 2 m1 L1 t minus 2. Yes, so A value is 1, B value is 1, C value is minus 2, and N1 is mentioned 1. N1 is mentioned 1. So M1 value will be, as this is SI, M1 value is 1 kg, L1 value is 1 meter, and T1 value is 1 second. Here in new system, N2 value is required. N2 value, that is question mark, required. M2 value, L2 value, then T2 value. So remember, don't put blindly M2 is equal to 1 gram because second system is your new system. This is not CGS system. It is not asking that convert 1 Newton into CGS system. Don't think like this. So read the question properly. In new system, 1 unit of mass is 2 kg. In new system, 1 unit of mass is 2 kg. That means instead of in case of M2, you have to mention 2 kg. Here 1 unit of length is 5 meter, and T2 value, that is 5 second. It is given 5 second. I hope it is clear. Then we have to use the required formula. So working formula is N2 is equals to N1 into M1 by M2, power is A, then L1 by L2, that power is B, and T1 by T2, that power is C. Next, so M1 value is 1, M1 is 1 kg divided by 2 kg, the power is A value is 1, then 1 meter by 5 meter, power is B, that is 1. Next 1 second divided by 1 second, the power is minus 2. So kg cancel हो जाएगा, सेम यूनिट कैंसिल हो जाएगा इस टर्म से. Then the answer will be 1/2 power 1, that is 1/2 into 1/5 to the power 1, that is 1/5. 1/5. Here T2 value is what? T2 value is 5 second. Yes, we have written 1 second. This is your 5 second. So after solving, you will get first one is 1/2 power 1, that is 1/2. Then 1/5 power 1, that is 1/5. Next is 1/5 to the power minus 2, that is your 1/5 means 5 to the power minus 1 whole power minus 2. So here it is 1/2 into 1/5, 5 power minus 1 to the power minus 2, that is 5 power 2, that is 25. Yes, I hope it is clear. Yes, this is your 1/5, sorry, this is your 1/2 into 1/5, 1/2 into 1/5. Then after cancellation we will get 5/2. So this option is correct. 5/2 units of force, this one is correct. 5/2 units of force, this is your correct answer. So listen one thing. So first you have to read the question from which system to which system it is asking. Okay, so if it is asking about one dyne to new system, then in that case what you have to write? You have to put, instead of fast system you have to write CGS system. But here it is given convert 1 Newton to new system of unit. So first system is in SI and second system is in new system. Yes, I hope this type of question is clear to all of you. So in our next lecture we will discuss regarding our next applications, remaining 3 applications. Okay, so one by one we will discuss. Okay, so kindly like, share and subscribe this channel. So thank you and have a nice day.